All right, IM2 classes. We are working on factoring special products. Um, let's just get right into it. First one we're going to be doing is called what's a difference of squares. So we're going to have a perfect square minus a perfect square, and it factors just using this pattern. All right, so here's an example here. X squared minus 9. That would be x squared minus 3 squared. So it just factors into x plus 3, x minus 3. So it's the square root of the first term plus the square root of the second times square root of the first minus the square root of the second. Real simple. The hardest part is recognizing when it's a difference of two squares and then remembering the pattern. So when we go over this in class, you're going to want to have this written down probably multiple places so you can access it whenever you want. So difference of two squares, we're going to factor this here. So first thing I'm going to do, I'm going to write that pattern that we have. So if we have, um, let me put in, I'm going to color code something. So if we have a squared minus a b squared, where it's a perfect square minus a perfect square, that is going to be equal to the square root of the first one plus or minus square root of the second one. So, and that's supposed to be a minus. So a squared plus b squared, a squared minus b squared factors to a plus b times a minus b. All right, so we need to identify the a and b. So here, 9a squared. That would be the same thing. Square root of 9 is 3. Square root a squared is a. So 9a squared is the same thing as 3a squared minus 16. That is the same thing as 4 squared. So I'm just changing this so we can see that uh, this is our a, this is our b, and it's just taking the square root of those. And so this is going to factor. I'm going to write out, it's just two binomials. One's going to be plus, one's going to be minus. So our A comes first, 3A plus or minus B, 4. And that's it. All right. So number two here, 4A squared, I'm going to rewrite it as the square roots of these. So 4A squared, square root of 4A squared is 2, or excuse me, 4x squared is 2x. And then the square root of 1 is just 1. So that's our A and B. So this is just going to factor into our two binomials plus minus. So it's going to be 2x square root of the first term plus and minus 1. That's the square root of the second term. And that is it. Um, I guess we'll do one more example, but I want to keep this moving. So here, same thing. So I'm going to rewrite it as this square roots of those being squared. So square root of 4k squared is 2k. Square root of 25 is 5. So our A is 2k, B is 5. So just write out our binomials. So it's going to be 2k plus and minus 5. Right? Next type of problems we're going to do are factored completely. So these are called perfect square trinomials. So what's going to happen is this is going to factor into our binomials are identical, and then we just write it as a perfect square. There is a pattern to this. I want you to practice with the X factor more. If you recognize the pattern, you're more than welcome to use it. But as we get into more quadratic stuff, we will switch over to using the pattern exclusively. But for this, for right now, until you recognize the pattern on your own, we are just going to factor it like normal. So I'm going to use my X factor or the diamond, whatever you want to call it. 16 goes on top, 8 goes on bottom. Two numbers that multiply 16 and add to 8. So that's 4 and 4. Since this doesn't have a number in front of the x squared, we can use our shortcut on this and put the size of the diamond right into our factors. So x and x, so they're both going to be x plus 4 using that shortcut. So x plus 4 times x plus 4. If you notice, those are identical factors since that's a perfect square. So what we're going to do is write this as x plus 4 squared. I don't know why I wrote 2. Um, and there we go. So we have our perfect factors there. And that's it. So once you have identical factors, squish them together, write it as that factor squared. Um, one more problem. So here, like I was saying, there's a shortcut. Eventually, you're going to get down to it so you can actually recognize this is a perfect square trinomial. This is going to factor to 5r minus 3 squared. I'm just going to write that off to the side. The shortcut, again, if you start noticing the pattern, you want to use a shortcut, you are welcome to do that. But for right now, um, we are going to just do it like we've been doing with the X factor. So since this has a number in front of the square term, I need to multiply these two together. So this is getting multiplied. So 25 times 9 is 225, negative 30 on bottom. Factors of 225, that is negative 30, that's going to be negative 15 and negative 15. Since I have the 25 in front of the r squared, I can't use the shortcut. So what I'm going to do is take this negative 30 and split it into a negative 15r plus a negative 15r. So again, negative 15r plus negative 15r is negative 30r. I'm going to bring down the rest of the polynomial. So 25r squared minus 15r plus negative 15r plus 9. And now I'm going to do my factor by grouping step. So I group the first two terms together, last two terms together. Make sure you keep that negative with the 15r, that second negative 15r. And then factor using GCF on each grouping. So the greatest common factor of 25r and 15r is going to be 5r. So 5r on the outside. When I divide that, 25 divided by 5 is 5. R squared divided by r is r. 15r divided by 5r is 3. So minus 3. Plus, largest thing that divides negative 15 and 9, it's 3. Since that 15 is negative, I need to divide by negative 3. So it'll be a negative 3 on the outside. Negative 15r divided by negative 3 is positive 5r. 9 divided by negative 3 is negative 3. Regroup the factors, regroup in our factors. So the first grouping is going to be our GCS factored together. So 5r, or our GCS grouped together, so factor together. 5r minus 3, and then the other 5r, those identical factors, is the last factor here. So we get 5r minus 3 times 5r minus 3. That's a lot of 5r's minus 3's. Since they are identical, we squish them together for our answer. All right. And that will do it for this. Next time, we're going to put everything together and factor completely. See you then.